Sure, yeah, we're talking about this problem is from the Think Academy. So it mentions several numbers has a constant sum of the 25. So what is the maximum product of these numbers? So we have two cases. The first is all the numbers are different. The other one is we allow the identical numbers. So basically, we have 4 claims for this one. The first is how to if the sum of some numbers are constant and what's the maximum of the product. It's basically using the equality between the arithmetic mean and the geometric mean. And it will be talked about in the future. We can talk about in very brief ways. So I have 2 claims. If we allow the number to be identical, so then the spacing of the numbers should be less or equal 1. And if we're requiring the different numbers, then the spacing of the numbers should be less or equal than 2. And the claim 2 is all numbers should be 2 or 3, as in this case, and the number of 2's should be less than 2. So let's prove the claim 1a first. So let's see if we allow the same number. For example, just assume 1 times a times a equals a squared. We can split the even number. Then we can decrease one number by 1 and increase another number by 1. So you can see the a minus 1 times a plus 1 is the a squared minus 1. So the product becomes smaller. So you can see to make the product as big as possible, you should make the number as close as possible. And if we have the sum of the odd number, that's 2a minus 1 is odd number. So if you can see, if we increase one number by 1, and decrease another number by 1, so it will be the same number, the minus 2. So whenever you diversify the 2 different numbers, then the product decrease. So the same thing we can prove the claim 1b, and now let's prove the claim 2. The claim 2 is, so we can only allow the 2 and 3, and let's see a case. For a number, okay, if we are greater than 5, greater equal than 5, for example, the a minus 3, and times the 3, so the sum of them is a, so the product is the 3a minus 9. We want this one greater than a. What is the criteria of the a? So we see a greater or equal than 5. So that means for any numbers of 5, we can split into the 2 plus 3 and make a product of 6 that greater than 5. So for any number greater or equal than 5, you need to split them. And let's see the step 2. 4. How about 4? 4 is 2 plus 2, and 2 times 2 is 4. So when you split the 4, and so the maximum product what you get is only 4. And now we prove the claim 3. The claim 3 is, so assume the number of 2's should be less or equal than 2. Let's assume we have the 3 2's. So 2 plus 2 plus 2 is equal to 3 plus 3. That's 6 equals 6, right? But 2 to the 3 is 8. Less than 3 times 3 is 9. So that means for any kind of the 3 2's, you can, through the rearrangement, make the 2 3's to increase the product. So now let's see what's this. If the 2 numbers if the numbers have to be different from each other, so basically we want the number spacing is 1 or 2, as 1 is the preferable. So 3 plus 4 plus 5 plus 6 plus 7 is 25. So this is the maximum product. Okay, then in case 2, we try to as much as the 3 as possible, right? So it's the 25 divided by 3 is 8 remainder 1. So we have another 3 becomes the 4, and the 2 is the 2 square. So 3 to the 7 and times 2 to the 2. So that's all. Thank you.